Okay, solve the following equations. Log x with log x minus 1 is equals to log 4x. Log x base 2 minus 1 less than 3. Log x base 3 minus 4 is equals to log x minus 1 minus log of 3 over x plus 1 is equals 0. Don't forget to subscribe, like, share this channel. If you subscribe it, don't forget to like it. Now let us start from questions number 1. Log x minus 1 base 2 less than 3. Now to solve this, first we need to find the domain. The domain for this is x such that x is greater than 1. So now let us solve it. Now the given expression says that log x minus 2 in base 2 less than 3. Now this is the same as log of x minus 1 in base 2 less than 3 times 1, since 3 times 1 is which is 3. Again, this can be expressed as log x minus 1 in base 2 less than 3 times log of 2 in base 2, because log 2 base 2 is which is 1, therefore which is the same as these expressions. So again, by properties of logarithmic functions, this can be written as log of x minus 1 in base 2 less than 3 less than log 8 base 2, because this can be expressed as log of 3 times log of 2 base 2 is the same as log of 2 to the power of 3 in base 2, but 2 to the power of 3 is 8. Therefore, we have log of 8 in base 2. So log of x minus 1 in base 2 less than log 8 in base 2. This is true if, since they have the same base, therefore this is true if and only if the exponents are the same. So that means x minus 1 is less than 8. Again, by rearranging this or by adding both sides by plus 1, we have x less than 9. Now, is x less than 9 is not only solutions based on the domains. Our domain is x greater than 1. Therefore, our solutions becomes 1 less than x less than 9. Because, for instance, if we say only, or if the solution is x less than 1, less than 9, for instance, if we give since x less than 1, for example, 0 is less than 9, therefore, if we substitute here, 0 minus 1 is minus 1. This is undefined because the domain of logarithmic function is positive real number. So this should be less than 9. Again, based on this, the domain x should be greater than 1. So our solutions becomes 1 less than x less than 9. Or in other ways, for instance, if x is greater than 9, for example, if x is 70, then 70 minus 1 is which is 16. Therefore, log of 16 in base 2 means log of 2 to the power of 4 in base 2, which is 4. 4 is less than 3, which is 4. So therefore, our solution should be 1 less than x less than 9. Log x minus 4 in base 3 is equals to 2. Again, to solve this, first we should find the domain. The domain for this expression is x such that x is greater than 4, because the domain for log of x in base b, y is equals to log of in x base b is positive real number. That means 0 to positive infinity, or x such that x is greater than 0. So here x minus 4 is greater than 0, then by solving x, then x is greater than 4. So the domain is x such that x is greater than 4. Now to solve this, the expression is given log of x minus 4 in base 3 is equals to 2. Now, by expressing this in exponential form, that means log of, or y is equals to log of x base b, if and only if x is equals to log y in base b, or b is the power of y. So, by expressing this in exponential form, that means log of x minus 4 in base 3 is equals to 2 if and only if x minus 4 is equals to 3 to the power of 2. But 3 to the power of 2 is 9, then we have x minus 4 is equals to 9. Again, by adding both sides 4, or by rearranging this, we have x is equals to 13. Therefore, 13 is greater than 4. Therefore, Thus our solution is x is equals to 30. Log of x plus log of x minus 1 is equals to log 4x. Again, to solve this first, we need to find the domain. Now the domain for this is, which is here x, therefore this x should be greater than 0, and here x minus 1 should be greater than 0. Here from this, x minus 1 is greater than 0 implies that x is greater than 1. Therefore, the intersection from this x greater than 0 and x minus x is greater than 1 is which is x is greater than 1. So the domain is which is given as 1 to positive infinity, or x such that x is greater than 1. So we can solve like this. Log of x plus log of x minus 1 is equals to log of 4x. Now by applying the properties of logarithmic functions, now one of the properties of logarithmic functions says that log of u times v in base b is the same as log of u in base b plus log of v in base b, or log of u in base b plus log of v in base b is the same as log of u times v in base b. So this expression is log of x plus log of x minus 1 is equals to log of 4x. Here we have natural here using common logarithms. Here we have 10, and here 10 base 10 10 10. Therefore this is the same as, by the properties, this is the same as log of x times x minus 1 is equals to log of 4x. Here they have the same base 10 10. So this is true if and only if x times x minus 1 is equals to 4 times x. This x times x minus 1 is the same as, which is x squared minus 6. Here we have 4x, therefore x squared minus 6 is equals to 4x. Now by rearranging this, we have x squared minus 5x is equals to 0. Here we have x common, so x into x minus 5 is equals to 0. Now this is true if x is equals to 0 or x minus 5 is equals to 0. That means x is equals to 0 or x minus 5 is equals to 0. Here x is minus 5 is equals to 0, then that means x is equals to 5. Therefore the values of x is what? X is equals to 0 or x is equals to 5. But our domain is here 1 to positive infinity, or x such that x is greater than 1. But x is not greater than 1, or x is equals to 0 is not in the domain, so the solution is only x is equals to 5. So our solution is x is equals to 5, because x is equals to 0 is not in our domain, so the solution is x is equals to 5. Log of x minus 1 minus log of 3 over x plus 1 is equals to 0. Now to solve this first, let us determine the domain. The domain for this is 1. X minus 1 should be greater than 0. X plus 1 should be different from 0, as well as x plus 1 is greater than 0. So by taking the intersections here, the domains for this becomes, which is x such that x is greater than 1. And x should be different from minus 1. Now to solve this here, log of x minus 1 is equals to log of 3 over x plus 1 is equals to 0. Now by taking this into the right hand side of the equal side, then we have log of x minus 1 is equals to log of 3 over x plus 1. Here they have the same commas in the same base, which is base 10, base 10. So log of x minus 1 is equals to log of 3 over x plus 1, if and only if x minus 1 is equals to 3 over x plus 1. Now by crisscrossing here, we have x minus 1 times x plus 1 is equals to 3. But x minus 1 times x plus 1 is the same as x squared minus 1, and here we have 3. So x squared minus 1 is equals to 3, then adding both sides 1 1, we have x squared is equals to 4. So what is the values of x? X is, which is plus or minus 2. X is equals to plus or minus 2, but our domain says that the domain is x such that x is greater than 1. Therefore, minus 2 should not out as solutions. And x is different from minus 1, so our solutions becomes what? X is equals to 2, because x is equals to minus 2 is not in the domain. Thus, the solution is x is equals to 2. Thanks for watching my video. Dear, don't forget to subscribe, like, share this channel. Thanks.